Okay, we're going to find the empirical formula of a compound that consists of these percentages of each of these elements. And remember that these percentages we can just change straight into grams. Don't overthink it. Where you see a percentage sign, replace that with grams. So in order to keep track of what we're doing, we're going to find our moles of each of these elements. And so I'm going to write moles of carbon because this is our map. This is what we're looking for, right? And we are given 39.99% carbon, which tells us we have 39.99 grams of carbon. And in order to get rid of grams of carbon, what can we use in order to do that? Well, we use our atomic mass. So we know that every carbon weighs, or every mole of carbon weighs 12.10 grams per 1 mole of carbon. And that means we can do this, and now we have, moles of carbon on top. And we're looking for moles of carbon, so that's where we want to stop. We're going to go to our calculator, and we'll type 39.99 divided by 12.01, and that means we have 3.33. We go to 4 significant figures. So we have, we have 3.32972. Let's write that, 3.3297. Oh, I think I got that backwards. 972. Okay. We want 4 significant figures, so we underline the 4 we need. We look at one more. That changes this to 3.330 moles of carbon. All right, now let's do hydrogen. Let's do a different color. So we're looking for moles of hydrogen. And we're given 6.73%, and we know that we just changed that to 6.73 grams of hydrogen. Then we use the molar mass. So 1 mole of hydrogen weighs 1.008 grams. And cross this off, and we get 6.73 divided by 1.008. We get 6.67658. 6.67658. All right. We want 4 significant figures. Look at one more. And we get 6.677 moles of hydrogen. All right. And now we're going to do oxygen, which we want moles of oxygen. And we were given 53.28%, but we know we write it as grams of oxygen. And oxygen weighs 15.999. We'll do 15.99 grams per 1 mole. And that gives us 53.28 divided by 15.99. 3.3320. 3.3320. Look at the 4 we need. Look at one more. 3.332 moles of oxygen. Okay, we're not done yet. So we found our moles. And now we need to find the smallest ratio. So what we do is we divide all of the moles by the smallest amount that we have. So this is a little bit tricky. And it's a good thing we went to 4 significant figures because we have 3.332 here. And then we have 3.330 here. So I'm going to say that this is our smallest. And we're going to divide this number, we're going to divide all 3 by this number. Okay, let's do it in a main color. So we're going to do, let's start with carbon. We have 3.333, 0 moles divided by that number, because that's our smallest number. That gives us 1 carbon. Okay, we'll do a hydrogen. We have 6.677 moles of hydrogen. We're going to divide that by our smallest number. Stays the same. And let's go do that. 6.667. Oh, I already forgot the number. 6.677. 6.677 divided by 3.33. And we get 2.005. Which just gives us a 2. All right, because we're looking for whole numbers here. These are our subscripts, so we want whole numbers. And then last but not least is 3.332 moles of oxygen divided by, and I'm not even going to use the calculator, I'm just going to say that that is 1 oxygen. And so our empirical formula, we just take these numbers we just found and we put them as our subscripts. So we have 1 carbon, see here, 1 carbon. We have 2 hydrogens and 1 oxygen. Just like that. And the way to best write the combustion equations is to remember chocolate. They go in the order of carbon, hydrogen, and oxygen. C-H-O, chocolate. So that's our empirical formula. Let's go back up and make sure that we have an answer, and we do. It is B.